Once you're done with the paragraph, so as we are answering, we'll be referring to the table. Yes, somebody to read for us. Hey, Mr. Emmanuel, this is your other account, huh? Okay, so meaning when don't unmute your mic because we'll get feedback. Very bad feedback. So once you have logged in with this one, just choose one device. Okay. Yes, somebody to read. Colleagues, it's kind of a long question. That's why I don't want to read. Okay. I'll be doing a lot of explanations. And remember, I'm not a papa. Okay. Papas are used to speaking for 2 hours straight. Okay. 2 hours straight. Okay. So yeah, somebody to read for us. Madam Sylvia, could you read for us? Mhm. Good evening. Yes. Okay, so yeah, this is the airspace. Oh, actually, the question is not really that long. It's not really that long. Okay, yeah. So after that reading, then they show us the SPSS output. Okay, meaning it's a software that did this for us, and we've got all this information here. All right. So we start with the questions first here. Then, as we answer, we are going to go to. I'll be referring also to the table. So the first question is saying state the measurement scale over the variables. All right. So gender, the measurement scale for it is the nominal scale. Okay. A nominal scale is just names or labels. Okay. It's not any numbers and there are no values. Okay. It's just a name or a label. Okay. So gender, nominal scale. Okay. Just a label or a name. In that document I sent for you, also at the bottom of that document, you're going to see these types of scales. All right, you're going to see them. Mr. Emmanuel, you're entering again. How many devices are you using? Yes, nominal scale, where it's just a name or a label. Then, level of education is the ordinal scale. This one usually deals with order. Okay, it categorizes things in order. Okay, in a certain order. So level of education, we know that there is a certain order of level of education. There's primary, there's secondary, there's university. Okay, so nominal scale, just a name or a label, no values attached. Level of ordinal scale is based on a certain order of things. All right, you cannot go into secondary minus primary education. You cannot go into university minus secondary education. Any questions? Part B, how many employees took part in the study? Okay, so he, under degree of freedom, he lists 473. This is the number of people who took part in a study. Okay, under here, degree of freedom, on this total column here, 473, that's the number of people who took part in the study. Any questions? Okay, now we come to some. Mhm. Good evening. Ordinal. Yes. It goes in line with order. Part C, use the p-value rule to comment on the statistical significance of all the independent variables. Well, I forgot to mention one thing. This test that we're doing here, all right, what we're trying to see how salary is affected by the gender of the employees, the age of the employees, the level of education, and the previous workers. Okay, colleagues? Our dependent variable is Mr. Emmanuel. Now, number four, how many gadgets? Four gadgets? Okay, yes. Our dependent variable is the salary. Then the independent variables is gender of the employee, the age, the level of education, and the previous working experience. Okay, colleagues? That's what this linear regression is about. How salary is affected by the gender, age, level of education, and previous working years. Are we okay with that part? Because I was supposed to mention that at the first. Yes. So, colleagues, what is the p-value rule from the last question that we did? What is the p-value rule? Yes, if it's below 0.05, then there's a significant relationship between that variable, the independent variable, and the dependent variable. Okay. So we have to comment on the statistical significance of all the independent variables. So we'll start with gender. This is our p-value here, 0.00000000. What can we say about that, colleagues? Mr. Chimonia, what can we say about the significance there? Mr. Foster? Hey, colleagues, why are we quiet? Yeah. Yes, yes, they are the independent variables. Yeah, no, 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 we're not here yet. We're not here yet. But we are here on the significance levels or the p values here. Yes. So this one is 0.000. So what can we say about, is it a significant variable? Yes, it's significant. It's less than 0.05. Okay, so we can say the gender of the employees has a significant relationship with the salary. Okay, so it seems, I think this test was done in the 1940s when equality wasn't there. Okay, there was no women inequality. Because nowadays, colleagues, the gender doesn't really define your salary. Okay, but in this case, it does have an effect on your salary. Any questions? Okay, the next one we have is the age of in years. Yes. I haven't seen any yet. I won't say there's nothing like that. I haven't seen yet. Since negative is way less than, so I would say it's still significant. This is still less than positive 0.05. Should there be such a thing? Yes. But I'll research, okay? Colleagues, we should research if there's ever a case where you have a negative p value. Okay. Because some of you in your fourth year researches, you'll be doing this with SPSS. Okay. Yes. So what can we say about age in years? Is it significant or not? It's significant, yes. Less also than 0.05, yes. Okay, level of education in years 0.00, also it significant. All right. Then previous working experience. Hey, this one is great. This one's greater than 0.05. So here, this one doesn't have any significance, the previous working experience. Any questions? We are looking at multiple linear regression. Remember, a linear regression is how we show a mathematical relationship between a dependent variable and independent variables. Okay. So here we're trying to see the relationship between the salary of a person, which is the dependent variable. We want to see how it's affected by the gender of the employees, the age of the employees, the level of education, and the previous working experience. Okay, these four things are the independent variables. These are the ones that are supposed to have an effect on salary. Is that okay, Mr. Who asked that question? Okay, yes. So what we're just looking at here, which were finished, we're just trying to see these independent variables. We want to see if they've got a significant relationship with what do you call this? The salary. So we're using the p-value rule. Okay, the p-value rule. If your value is less than 0.05, okay, then there is a significance in the relationship. Okay, but if your value is greater than 0.05, then there is no significance in the relationship. Is that okay, Mr. Daniel? Mr. Dennis? Okay. Interpret the regression coefficient associated with the level of education. Okay, we come to these unstandardized coefficients. Okay, so level of education 650.548. So what it means is if you increase your level of education by 1 year, your salary increases by 650.548. Okay. If you increase your level of education by 1 year, salary increases by 650.48. We won't use percentages here because that is a very high percentage. So we just use years, 1 year or 1 unit. But that unit can equate to 1 year. Any questions? Which variable has the greatest impact on the starting salary? So for this one here, we can also review the p-values to see which one has got the lowest p-value with the most significance. Now in this case, we have two: gender of employees and level of education. As you can see, both of them are 0.000 and here is 0.000. Okay. So I would pick level of education. Okay. Or you can pick the gender. And justifying your answers, you're using this p-value or rule. Okay, so against the level of education or the gender, because both of them have the lowest p-value. Any questions before we move to part F? Okay, now this part where they're saying calculate the coefficient of multiple determination. This coefficient of multiple determination is this adjusted R, the adjusted R. If you remember in that previous question there where they asked about adjusted R, they're talking, that's the coefficient of multiple determination. And what does the adjusted R tell us, colleagues, from last time? What does the adjusted R tell us? The calculate part, I'm still trying to find out where they meant to calculate, but what I know is adjusted R is the coefficient of multiple determination. And it tells you how good the independent variables explain changes in the dependent variable. How good the independent variables explain the changes in the dependent variable. So you can say if there's any change in salary, right? If there's any change in the salary, 48.5% of that change is due to these independent variables. Where the other 50%, we don't know what's causing the change, but we know that 48.5% of that change in the salary is due to these variables. So when commenting on the adjusted R, that's how you say. For any change in salary, 48.5% of that change is due to the independent variables. Then the remaining percentage, we do not know what is causing, what is the cause of what the other things are that are causing the salary. There's some other variables that cause the change in salary, but we don't have them in our model here. Yes. Any questions? Adjusted R squared. Adjusted R squared. So you're going to say if there's any change in salary, 48.5% of that change is due to the independent variables. Okay. Then the remaining 100 minus 48.5, I think that's 41.5%. The remaining 41.5%, we do not know which variables are causing that remaining change in the salary. It's unknown. They're not in this model here. We can only account for 48.5% of the change in salary.